Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Today, we're diving into what might be the biggest shift in DevOps since containers. GitHub Universe 2025 just announced Agent HQ, a mission control where you orchestrate agents from OpenAI, Anthropic, Google, and Cognition all in one place. Their COO said they want to bring order to the chaos of innovation.
And that sounds great in theory, but here's the question nobody's asking. What happens when the chaos is inside your production systems?
That's the tension we need to unpack because the productivity numbers are real. Azure SRE Agent saved Microsoft over 20,000 engineering hours. But so are the risks. 80% of companies report AI agents executing unintended actions. Only 44% have security policies for agent-specific threats.
23% have witnessed agents revealing access credentials. So we've got revolutionary productivity on one side, unprecedented security exposure on the other. Platform teams are caught in the middle.
Exactly. So today, we're going to explain what Agentic DevOps actually means beyond the marketing. We'll show you the new threat model for autonomous systems, and we'll give you a framework for adoption that doesn't create catastrophic risk.
Let's start with what GitHub actually announced. Agent HQ is their multi-agent orchestration platform. You assign tasks to agents, steer them, track their progress, all from one interface. The interesting part is it's agent agnostic. You can use Claude from Anthropic, GPT from OpenAI, Gemini from Google, Devon from Cognition, Grok from xAI. They're all available through your Copilot subscription.
So GitHub's positioning themselves as the control plane for the entire agentic ecosystem.
That's exactly right. They call it any agent, any way you work. And they've built an enterprise control plane for governance at scale. The idea is you shouldn't have to manage each agent individually. You need unified visibility and policy enforcement across all of them.
Makes sense from an operations perspective. What about the Copilot coding agent specifically? That's the one that's going to hit most teams first.
So this is fundamentally different from autocomplete or chat assistants. The coding agent works asynchronously in the background. You assign it an issue or ask from VS Code, and it spins up a secure GitHub Actions environment, reads your repo context, decides on an approach, writes code, and pushes commits to a draft PR. You can track everything through session logs, but the agent is working while you're not.
Working while you sleep. That's the pitch, right?
And it's not just marketing. This became generally available in September 2025 for all paid Copilot subscribers. They also introduced agents.md, configuration as code for custom instructions. You tell the agent things like, prefer this logger or follow this testing pattern. It's like a README, but specifically for agents.
Okay, so that's the developer productivity side. What about the operations angle? That's where Azure SRE Agent comes in.
Right. Azure SRE Agent is designed for production operations, continuous monitoring, anomaly detection, AI-suggested mitigations. The headline number is root cause analysis in minutes versus hours traditionally. Microsoft internal teams saved over 20,000 engineering hours using this.
20,000 hours. That's roughly 10 full-time engineers for a year.
And the key detail here is it's human in the loop by default. The agent suggests, but humans approve. That's intentional. They're building trust gradually before expanding autonomy.
That sounds reasonable, but let's talk about the security reality, because that's where this gets complicated.
Let's start with what agentic actually means, because this is a fundamental shift that I don't think most teams have internalized yet. Traditional automation executes predefined steps. You write a script that runs kubectl apply or Terraform plan. The system does exactly what you told it to do.
No surprises, no decisions, just execution.
Exactly. Agentic is different. The system reasons about goals, plans actions, and executes without specific instructions. It makes decisions based on context, not just rules. It can chain tools together, access resources, and modify systems in ways you didn't explicitly define.
Wait, so the agent decides what to do?
That's exactly right. You give it a goal, fix this bug, or investigate this latency spike, and it figures out how. It reads code, decides which files to modify, chooses which tools to use, and executes that plan. The power is obvious, but so is the risk.
Walk me through the technical flow. What actually happens when you assign an issue to the Copilot coding agent?
The agent spins up a secure dev environment via GitHub Actions. It reads your repo context, code, docs, agents.md, configuration settings. Then it decides on an approach. Not you, the agent decides. It writes the code, pushes commits, and you can track all of this through session logs. When it's done, it opens a draft PR for you to review.
So human review happens at the PR stage.
Right, but think about what that means. By the time you see the PR, the agent has already made dozens of decisions. Which files to touch, which patterns to follow, which dependencies to use. The PR is the output of all those decisions. You're reviewing the result, not the reasoning.
That's a different security model than we're used to.
Completely different. Traditional security puts the trust boundary at user input. You validate what comes in, you review code before it merges. Agentic security, the agent is the user. The agent writes the code, so who reviews the agent?
Let's talk about specific threat vectors. What are we actually worried about here?
OWASP's GenAI security project identified 15 distinct threat vectors for agentic systems. Let me walk through the big ones. First is prompt injection. Google's security team has documented how hidden content, HTML comments, white text on white backgrounds, even calendar invites, can contain malicious instructions that agents follow without question. An agent reads a web page or document, sees the hidden directive, and executes it as if it were a legitimate instruction.
Hidden HTML comments. That's not even sophisticated.
That's what's scary. The attack surface is huge because agents consume data from everywhere. Code comments, documentation, web pages, API responses. Any of those could contain instructions the agent follows.
What about tool misuse?
This is when agents with overly broad permissions pivot across networks or exfiltrate data. The example I keep coming back to, if a web reader agent has overbroad permissions, a single indirect injection can let it access your corporate wiki and harvest secrets. The agent is just doing what it was trained to do, following instructions. It doesn't know the instructions are malicious.
Privilege escalation is the third one, right?
Yeah, this is particularly nasty for DevOps. Imagine a DevOps agent with cluster admin access because someone gave it broad permissions for convenience. An attacker poisons a Git commit with hidden instructions. The agent reads that commit as part of its context, follows the instructions, and creates privileged pods that expose secrets. And here's the worst part. The attack uses valid credentials, so it looks legitimate in your logs.
The logs show authorized access because the agent had the permissions.
Exactly. You can't distinguish the attack from normal operations without looking at the agent's decision-making process.
What about the code the agent generates? That's production code, potentially running in critical systems.
This is the remote code execution vector. There's a natural tendency to treat AI-generated code as trusted because it came from your system. But the LLM follows untrusted input, prompts, context, examples. That means the code it generates is also untrusted. You need to sandbox execution and validate generated code before trusting it. Don't let agents push directly to production paths.
Okay, so we've got prompt injection, tool misuse, privilege escalation, remote code execution, but there's another problem, the shadow agent issue.
Right. There's been a sharp rise in shadow agents deployed without IT visibility. Developers are becoming one-person R&D departments. They spin up agents to help with their work, give those agents their credentials, and nobody in security or platform teams knows they exist.
And if that developer's identity is compromised,
The blast radius is massive. Developer identities are becoming the most powerful identities in the enterprise. They have access to code repos, CI/CD pipelines, production systems, cloud credentials. An attacker who compromises a developer identity now potentially controls every agent that identity has access to.
so we've got these real productivity gains, Microsoft's 20,000 hours, the async development model, faster incident response. But we've also got 80% experiencing unintended actions, 23% seeing credential exposure. How did teams square that?
That's the paradox. The technology works. The productivity gains are real and substantial, but only 44% of early adopters have agent-specific security policies. Most teams are deploying agents with the same security posture they use for traditional automation, and that's a critical mistake.
Why? What's different about the security model?
Autonomy invites unpredictability. With traditional automation, the failure modes are bounded by the script. The script does X, or it fails. With agents, the failure modes are bounded by the agent's capabilities. What can it access? What tools can it use? What permissions does it have? The answer to those questions is your actual attack surface.
Give me a real-world example of this going wrong.
Security researchers have documented multiple cases of agentic AI coding assistants being exploited for data exfiltration and credential theft. The pattern is consistent. Attackers find that the agent's broad access becomes the attack vector. This isn't theoretical. It's happening now, and the documented incidents are growing.
Okay, so what's the mental model shift teams need to make?
4 key changes. First, don't treat agents like trusted code, treat them like untrusted input. Everything the agent produces should be validated like it came from an external user. Second, don't give agents your permissions. Design least privilege specifically for agents based on the actual tasks they need to perform.
So not agent gets my access, but agent gets minimal access for this specific task.
Exactly. Third, don't assume logs tell the truth. Agents with privileges can mask their tracks. You need to log every decision the agent makes, the context it retrieved, the tools it invoked, the arguments it passed, the results it got, immutable logs that can't be erased.
And fourth?
And don't let agents work in the dark. Full transparency into their reasoning, not just their outputs.
Okay, let's get practical. How should teams actually adopt this? Because don't adopt it isn't realistic. The productivity gains are too significant to ignore.
I'd break it into 3 tiers based on risk. Tier 1 is low-risk starting points. This is where you should begin. Code review assistance, not autonomous commits, but having agents analyze PRs and suggest improvements. Documentation generation, test writing suggestions, issue triage, and labeling. The key constraint is human approval before any action.
So the agent helps, but doesn't act.
Right, you're building trust and understanding the technology without giving it the ability to break things. Tier 2 is medium risk with guardrails. Autonomous commits, but only to draft PRs, access to non-production environments, sandboxed code execution, time-boxed agent sessions so they can't run indefinitely, automatic rollback on anomaly detection.
What makes something tier 3?
Production access. Production monitoring, like the Azure SRE Agent model, incident response automation, infrastructure changes via IAC, Terraform plan before apply. The requirements for Tier 3 are strict: immutable logging, true least privilege, and human in the loop for any critical action. Most teams should not be in Tier 3 yet.
Let's talk implementation. How do you actually enforce these tiers? Because don't adopt it isn't realistic. The productivity gains are too significant to ignore.
Agents.md is your first tool. Use it as a security boundary, not just a style guide. Define what the agent can and cannot do per repo. Prefer this logger, but also never modify production configs, never access secrets directly, never push to main.
Organization level defaults?
Yes, you can set organization-level agents.md that applies to all repos, then override at the repo level for specific needs. Second, Treat agent output like user input, sandbox execution, validate generated code before trusting it, no direct production access.
What about monitoring?
Monitor agents like you monitor microservices. Event monitoring for every agent decision. Context retrieved, tool invoked, arguments, results. Immutable logs that attackers can't erase. You need to be able to reconstruct what the agent was thinking, not just what it did.
And provisions.
Least privilege per task. Code review agent gets read access to code and write access to comments. That's it. Deployment agent gets read access to config and write access to specific resources. You never give cluster admin for convenience. Every permission expansion should be justified and documented.
When should teams wait? What are the prerequisites?
If you don't have robust RBAC today, don't add agents. If you can't audit what humans do in your systems, you can't audit what agents do. If your secrets management is weak, agents will find and leak them. The security foundation has to be solid before you add autonomous actors.
Let me summarize the framework. Tier 1, agent assists, human acts. Tier 2, agent acts in sandbox environments. Tier 3, agent acts in production with strict controls.
And treat agents as autonomous actors, requiring the same security rigor as production microservices. Not as tools, not as automation, as actors in your system with their own attack surface.
The question isn't whether to adopt Agentic DevOps, it's whether you'll adopt it before you're ready to secure it.
Azure SRE Agent's 20,000 hours saved is the future, but 80% experiencing unintended actions is the present. The teams that get this right will have autonomous systems that accelerate delivery. The teams that don't will have autonomous systems that accelerate breaches.
Sometimes the most powerful technology requires the most careful adoption.
And the first step is understanding that these aren't just smarter scripts, they're autonomous actors. Plan accordingly.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.